Today we're going to learn how to graph a rational function. The rational function we're going to graph today is y equals 2x plus 2x divided by x squared minus 1. So the first thing we want to do is try to factor rational functions. We always try to factor rational functions. And from the top, what we're going to do is take out a 2x. That's going to leave us with an x plus 1. On the bottom, it's a difference of squares, so that's going to be x minus 1 and x plus 1. Now we can see that we could take out an x plus 1. And as we factor that out, that creates a hole in the graph. And the hole in the graph is at x equals negative 1. To find the y point for this hole, we just plug the hole, or the x point, into the factored equation. And as we do that, we get y equals 1. So the hole is at negative 1 and 1. The next step you want to do is find the asymptotes. So let's start out with the vertical asymptote. So vertical asymptote is where the denominator cannot equal 0. So what we're just going to do is we're just going to put we're just going to put x minus 1 and set that to equal to 0. And we're just going to isolate for x. And what you get is x equals 1. So x could never equal 1, or that would make the denominator equal 0. And you could never divide by 0, because that's undefined. So the vertical asymptote equals 1. Now we find the horizontal asymptote. And how we do this is we look at the highest x power, and we divide that over everything. So how that's going to look like is it's going to look like 2x divided by x divided by x minus 1 divided by x. And we're going to set x to a really big number. And when you divide by a number close to infinite, it just results as 0, or approximately 0. So we're just going to cancel out this one here, and we're just going to factor out the x's from here. And what you're left with is 2 over 1. And that equals, so the horizontal asymptote equals 2. Now the next thing we're going to find are the y and x intercepts. And how we do that is, for the y-intercept, we're just going to plug 0 in for the x, and for the x-intercept, we're just going to plug y equals 0. So for the y-intercept, it's just going to be equal to 0 over 0 minus 1, which just equals 0. For the x-intercept, we're just going to take the denominator to the other side, and when we times by 0, which is 0, so we can cancel the denominator. And then when you divide it by 2, 0 divided by 2 is just 0. So the x-intercept equals 0. So now what we want to do with this is that now we have to graph this. What we're going to do is we're going to place our asymptotes and the x and y intercepts on the graph. So the vertical asymptote is going to be 1, x equals 1. The horizontal asymptote equals 2, so that's just going to equals 2. And now y and x intercepts are the same, which are just 0 and 0. And now we want to determine the shape of this graph. And how we're going to do that is we're going to choose points on either side of the vertical asymptote. So we're going to choose points 0, 9, and 1.1. We're going to plug those x values into the factored form for the equation to get our y values. We're also going to choose 1000 for the x and also negative 1000 for the x. And what we're going to do is just plug those values into the factored equation to get our y value. So when you plug in 0.9, you times that by 2, and you divide that by 0.1, your y value is negative 18. So 1 point is 0, 9, and negative 18. 0.9. And now as you plug in 1.1, times that by 2, divide that by 0.1, you get 22. So another point on the graph is 1.1 and 22. And I'm just going to do those for the rest of the points and plot them on the graph, as seen in the video. And now since this is a rational function, it's being divided by something, we know that it's going to look like an asymptote graph. And an asymptote graph is where something approaches 0 or approaches something, but never actually reaches it. So this graph is just going to approach the vertical and horizontal asymptotes, but never reach it. It's going to get very, very close, but it's never going to touch the vertical or horizontal asymptotes. The more points you have on the graph, the better it is, the more precise it is. Also, remember never to go through the hole when you draw your graph. There's always going to be a hole at the -1 and 2. Never cross that point. Okay, thanks.